Okay, so good day everyone. So this will be our next topic, and some of these topics is within your manual, okay, which is for week 4 and week 5. So this is a static lateral force procedure, or some of the engineers also denote this as the code-based design. Okay, so code-based design for seismic. So, but before we proceed with these procedures, guys, we need to know some of the parameters, no, in order to understand all of the notations that will be included in the procedure. Okay. So first is the seismic code. So why is it that we have these codes? Since a code is a set of rules adopted by an organization empowered to enforce the code. Okay, so that is the main purpose of the code. Then second is the UBC. Okay, so the Uniform Building Code is dedicated to the development of better building construction and greater safety to the public. Okay, so the UBC, the most widely adopted model building code in the US, contains the most extensive seismic provisions for structures of any code. So, mao na ito ang gina-adapt guys daw natay NECP 2015, 2010 no, natay code, National Structural Building Code. Pero katong halos gipang adapt sa NECP guys is gikan to dali. Okay, so gikan to dali sa UBC. Okay? So many of the seismic provisions of the UBC have been influenced by the recommended lateral force requirements and commentaries published by the Seismology Committee of the Structural Engineers Association of California. Okay, so guys, then so the International Building Code and UBC 97. Okay, so the UBC 97 edition incorporates both the SEAOC Seismology Committee's recommendations for seismic design and the NEHRP recommended seismic regulations for new buildings. Okay, so mo ni ang updated guys as of today. Mao pa gid ang kuan UBC 97, no? Ang mga tuang ginagamit sa ato ang design. Okay, so the UBC has been acknowledged as the prominent code publication for earthquake design provisions over the last few decades. Okay, even now, no, UBC gyapon jud ang kuan guys, ang gina-follow na mga procedures for building designs seismic. Okay, so the new seismic provisions of the 1997 code exemplify a number of notable lessons learned from earthquakes and recent advances in other seismic resources documents, including the NEHRP. So the new provisions demonstrate a considerable migration from previously elected approaches in seismic design. Okay, so mao na guys. So murag ang gisundan man gud sa UBC 97 is UBC 95. So murag within that 2 years of span, so murag natoy time siguro nagdinong sa ilaha. So murag mo to guys, no, na nasa mga lesson learned from their previous earthquakes. So na guys, no, kuan gina siya, applicable gina siya. And even mga advances guys sa research, no, na siguro mga new discoveries, no, due to researches. So ilahan lang gi-incorporate dahil. Okay, so these are the provisions are as follows. So mao nito mga update guys na ilang gibuhat from UBC 95. So mao na yung mga update sa UBC 97. Okay, so new design response spectra based on 1997 and EHRP recommended provisions. So ato lang ni-discuss later guys kani response spectra na yung ginamin. New device based shear equations utilizing new soil profile types, seismic response coefficient, seismic source classification, and near source factors. So kani guys, bago pa niyo ma-discuss na to ni later guys. Kani sila. Okay, kani na si Kadoa. Then adoption of revised structure response modification factor based on elastic ground motion response. Kani pod guys, pero sa next topic na ni siya nato ma-discuss. Okay, kanang ginatawag na structure response modification factor. Adoption of strength-based design approach. Okay, so mga na guys, strength-based design siya. Acceptance of more precise evaluation of the drift induced in structures in response to design ground motion. So napo na sila yung mga drift limitations guys. Ang drift guys is kanang displacement at sa building na. So say for example, kung mo na yung mga building guys, then kuhanan og lateral load, so malihok man dyan na padulong dito, di ba? So exaggerate na guys ha. So kanang movement guys na from the original kanang na movement, so mo na ginatawag na drift. Okay, kanang horizontal movement. Okay. Then acceptance of the effects of structural redundancy, reliability, and overstrength factors. So introduction of new structural system classification. So cantilevered column building system to simulate buildings with discontinuity and capacity. So that is the weak story. Then shear wall frame interaction system and special truss moment frames of steel. So non-structural components provision consistent with the 1997 NEHRP. Then non-building structures provision consistent with 1997 NEHRP. Okay. So the survivability design criteria. So while little effort is extended in trying to design buildings that will be totally elastic, so pasabot guys is experience no damage during an earthquake, it is implicit in seismic codes that catastrophic collapse must be avoided. Okay, so mo na ang ilahang ginaiwasan guys kana. So based on the UBC 1997, the purpose of the earthquake design provision is primarily to safeguard against major structural failures and loss of life. So mao gyud ang purpose. Then these provisions are not intended to limit damage or maintain function. Okay, so mao na ang nakakuan guys, no, mao na murag naka dili sa problema pero murag mao na nakakuan gamay, nagka-diferensya no kay ang code man gud guys kaning si UBC 97 wala niya gi-promise na wala joy damage, no kana. So wala niya gi-promise na wala joy damage after the earthquake. Okay, basta ang gusto lang niya mahitabo is maiwasan ning catastrophic collapse sa building, which is kung maiwasan ang catastrophic collapse, then for sure there will be no loss of life. Tama, loss of life and also loss of your property. Okay, so mao na ang nakakuan sa code guys, code based design. So wala siya nag-promise na wala ginay damage, no? So ang iyaha i-allow niya ang damage, no? I-allow niya ang damage pero dapat dili mo collapse. Okay, if once mag-collapse, murag naay na jud na murag naay problema sa design and sa construction sa building. Okay, the following three design standards constitute the implied UBC seismic survivability or life safety design criteria. It is notable, however, that these criteria are not actually specified in UBC. Though, kuha na ni mga design standards. Okay, so the UBC provisions will not prevent, guys, kahungingan guys, will not prevent structural and non-structural damage from direct earth faulting, slides, or soil liquefaction. Okay, so mga mga kasagaran guys na mga cause sa earthquake kana sila. Si fault kana pag slide sa yuta, samot na po ng liquefaction. Delikado po ng liquefaction guys. Okay, so there should be no damage to buildings from a minor earthquake. Okay, so unta murag ana ba yang ginamin guys is unta walay damage kung minor lang na earthquake, no, kana mga magnitude 3 mga ana 4, so di pa magina siya major siguro kaya. So there may be some architectural damage. So mao na guys, murag i-allow lang niya na architectural damage lang, non-structural pareha na mga ceiling, okay, sa mga inana. But no structural damage during a moderate earthquake. Okay? So kana siya. So pwede makuha pero architectural lang. Siguro plastering pod guys. Paisa na siya. So there may be possible structural and non-structural damage but no collapse during severe earthquake. So pareha to mga na-experience na to last December. Okay, so mga to siya. So walay unta, walay damage, okay ra na yung mga damage gagmay, pero ayaw po nang ipa-collapse. Okay, so yielding is relied upon to dissipate the damaging seismic energy. Theoretically, all structural damage will be repairable. Okay, so mao na ang iyang gusto guys. Repairable when collapse is prevented. Although some buildings may be condemned. Okay, some buildings may be condemned and replaced for reasons of economics or convenience. Okay, so ang iyang pasabot guys is sample kung nice structural damage, so pwede ma-repair or kanang retrofitting na kinatawag mo man ang gilang term sa ato retrofitting kanang mag-repair sa building. Okay, kung makaya og retrofit then go. Pero pag tan-aw gani mo na murag dili na makaya na murag about to collapse or murag dili siya safe for occupancy, then that's the time maybe replace na pud nimo. I-replace or mo i-condemn, no, dili lang nimo pasudlan tong specific area na which is naay tan-aw nimo na murag alanganin na langanin siya i-occupy. So mao na guys, no, mao na itong mga 3 design standards, mao na itong mga timan-an pod. Okay, so wala siya nag-promise na wala jay ko. Okay, so effectiveness of seismic provisions. So the code provides reasonable but not complete assurance of protection of life. Okay, so magyapon na guys. No, so reasonable na siya. And also later makita na to, it is the minimum requirements. Okay, so minimum na siya. So kung napay kuan lain ng mga paraan na ma-lessen ang mga damage, then you should go from it, no? Or you do beyond the code. Okay, so muna ang iyahang gusto. Furthermore, the code does nothing to prevent construction on land that is subject to earth slides or liquefaction. So kung kaya man mapangitag paraan sa contractor, sa engineer na masing kabalo sila na possible ang earth slides o ang liquefaction, then mangita sila paraan kung saan nila pagpa-stabilize sa building. Okay, so mao nang dili pud nila i-prevent na kay na may lain engineering mitigation pa na pwede. So the level of protection can be increased by increasing the design lateral force, energy absorbing capacity, the redundancy or mga additional supports guys, and construction quality assurance. Ang problema lang ani guys, pag imo i-increase ning pag imo ni-increase ang design lateral force, then kana po mga energy absorbing capacity sa imong member, bara costly siya gamay. No, so costly siya. Mo na ang problema. Though maka-assured pud jud ka na murag maka-assured pud jud ka na murag ma-lessen ang effects sa earthquake. Okay? So kana. So for now murag good position option, redundancy. So mga additional supports, mga other members na dungagan yung mga members. Kani pud samot na ni construction. Kaya mas yun sa kagwapo sa design pero pag execute sa construction wala. Dili gyapon okay. Then it is important to note that seismic design is both a science and an art that unfortunately must be verified in the field. Mao gyapon na guys, so verification gyapon sa field. So thus, the history of seismic codes has been required design features or methods and then evaluate the effects of these features in the practice. No, kay basin naman ko yung mga naman ko sila yung mga kuan good provisions na sometimes ambitious guys, then pagabot sa actual murag lisod siya i-kuan, lisod siya i-execute. So imuha po ng tanawon later. So you have to evaluate. Okay. Finally, the seismic code use is not only the factor affecting the performance of the structure during an earthquake. So mao na yang gina-mean that the code is only the minimum requirements, no? Mao na siya. Siya gani mismo niingon na dili lang siya mao ang factor. So daghan pa. Or you can go beyond the code. Okay? So mao na siya guys. Which is mao nang one of the recent designs karon guys. Dili lang magsalig sa code. Okay, so natay ginatawag na PBD. Okay, kana guys, mo nang gina-adapt karon. PBD. So this is the performance based design. Okay, so ano siya guys, performance based design. So mao na ang latest karon guys. So which is dili na murag mostly sa kaning performance based design is not in the code, no? So doon na sa mga books na sa gina-practice siya no sa America 20 years ago pa sa America guys, and sa atoa murag bago-bago pa jud siya na-adapt. Okay, so mao na pinakagapo karon guys sa performance based design. Though complicated siya gamay, pero makaya lagad na kung maybe kung naka-experience din mga several workshops and studies. Okay. So seismic design criteria. Okay, so seismic design criteria selection. So the base shear, so which is V, na denoted as V na siya dali guys sa ato no, is the total design seismic force imposed by an earthquake on the structure at the base. Okay, so mo na kita siya base shear. Okay, kay ang ginahatag man gud na force sa earthquake is lateral, so which is shear na with respect to the members. Okay, so the base shear is the sum of all the inertial story shears. So the UBC 97 calculates the base shear from the total structure weight and then apportions the base shear to the stories in accordance with dynamic theory. So mao na ato ang mga ipang solve later guys kana si base shear, then sa una to pag distribute okay sa every story. So the design seismic forces can be determined based on the UBC 97 static lateral force procedure and or the dynamic lateral force procedure. So kani guys medyo kuan na ni complicated na pag once may kag dynamic. Okay, so more on static man gud na yung ato ang nadali guys. Static lateral pressure na kuan procedure. Okay, so based sa katong book na kung yata sa inyo guys katong Lindeberg na libro last time. So mo na yung mga gipanghatag ng mga criteria guys na though mo po with respect to UBC pa ni guys no nagapon ni sa UBC na code. Okay, so mo na yung mga kuan guys, mga steps no. Then dito sa book na yung mga sections dito para inyo ka mabasa no. Mo na yung mga considerations guys. So 7 ana. Okay, so 16 ka ba? Okay, so muna yung mga do isa-isaon na to ni guys na ako yung mga discussions ganun. Do not worry no, about these procedures. Hindi na ako basahan guys sama-sama ko na itong 16 ka criteria. Okay, so going through the criteria guys. So muna ni siya no, inayin na itong mga parameters guys kato sa mga procedure na nadala. So first, unahan sa nato na yung ginatawag na seismic zone factor Z. Okay? So, seismic zone factor Z accounts for the amount of seismic risk present in a building's seismic zone based on the anticipated maximum ground acceleration at the site. Okay, so mo na yung one basis, guys. Tungod sa maximum ground acceleration sa area, no, moto. Then sa US, guys, the 1997 provision provides 6 different seismic zones with 0 representing the least risk and zone 4 encompassing areas with a chance of severe shaking. Okay, so from 0 to 4 na so makita na to naman yung table, guys. So the value of the seismic zone factor are developed according to historical records, no, kung siguro kung kapila na si earthquake sa kuan kato na lugar, and geological data and seismological informations. Okay, so sa UBC 97, guys, with their table 16-I, so this gives the seismic zone factors for each of the zones. Okay, so mo ni ilang yata, guys. So mo ning unang kabo, guys. Kung nabilong, example, ang lugar nabilong sa seismic 0, so Z 0. Kung nabilong sa seismic zone 1, so mo ni mong factor for Z. Ang 2, guys, gimo niyan 2A, 2B, na. So 0.15 and 0.2. Then seismic zone 3, 0.3, seismic zone 4, so 0.4. Okay? So that is with the UBC. Pero pag abot sa ato, guys, kung moingon tag Philippine setting, no, so naman tayo NSCP 2015. So with accordance to table 208-3 sa NSCP 2015 gives the seismic zone factors in Philippine archipelago, which consists only 2. Okay, so duha lang dali sa ato, guys. Okay, sa Pilipinas, zone 2 and zone 4. So zone 2 covers the province of Palawan except Busuanga, Sulu, and Tawi-Tawi. Maura na sila lugar ang seismic zone 2 sa Pilipinas, guys. And the rest of the country is under seismic zone 4. So kung naunahon na to, guys, nata sa pinaka-peak, no? Or we have nata sa severe shaking, no? As indicated kaganina. Okay. Ang seismic 2 na to, guys, wala gihati og A and B, specific na gina 2. Worst case scenario. Okay, so 0.2, then 0.4. Okay, so muna diri sa ato sa Pilipinas. So may mapa, guys, na naihatag mapa sa NCP. So tanan na nadari, guys, tanan na nadari na lugar, zone 2. Then kanina nadari zone 4. Unsa kaya ang reason, guys, nganong sa zone 4, mostly zone 4, one Pacific Ring of Fire, no, so we are earthquake prone, no, na country, kinagyaan mata sa Pacific Ring of Fire. Okay, so ito, guys, so seismic zone factor Z. Okay, so the zone factor of 0.4 in zone 4 implies that the maximum base or the adjusted effective peak acceleration EPA is 0.4 G for the design earthquake. So mo ni siya ang kuan, guys. So mo nitong indicator kung seismic zone 4, 'di ba, natay 0.4 na factor. So i-multiply to siya dito sa ground acceleration. Okay, so 0.4. So pasabot kung nabilong ta sa zone 4, then 0.4 G ang ato ang peak acceleration. Okay? Pero sige lang, ako ipakita later, guys. So geographical region experiencing an EPA which is greater than 3 would classify 0.3 would classify to zone 4. Okay. Namatoy zone 3, 'di ba, sa kuan sa laing nasod. So ang zone 3 0.3 man to. Pero pag mobiyan ang ilang acceleration ng inana, so automatic zone 4. So these values are intended to represent the effective peak ground accelerations to have only a 10% chance of being exceeded in 50 years. So though gamay lang kaya ang chance guys, no? Gamay lang kaya ang chance na ma-reach ganyan na 0.4 G. Okay, ang acceleration within 50 years. Pero at least prepare tadaan na inanad ay ang atong gina-expect. Okay, gina-expect na earthquake. Okay, so kaning 0.4 guys, mura dili na ni siya applicable karon because of the update no made by P-Box. Ano kay pakita sa inyo ha. Okay, so we have this Metro Davao earthquake model guys. So this is designed by P-Box no. Sa study nila. Tulo ka city na ang nainani guys, the Metro Manila, Metro Cebu, and Metro Davao. Okay, so earthquake model. Ang kagwapo ni kay naka-focus gid sa ato So this is a probabilistic seismic ground motion hazard assessment of Metro Davao. So DOST P-Box dahil guys ang kan. So 2019 nila nagigawas guys. Kaya ito lang scan kamay. So dagan kina speech pa nandila guys. Okay, so kanino nyo makita na mga lingin guys. So this is the seismicity map of region 11 and vicinity, historical and instrumental. Okay, so habang dako ang kuan guys, pasabot ang experience dahil na kuan na lugar is ngani nagadako po siya kani siya. Okay, so nagadako panana sa region 11. Okay, so murag nalagay tayo mga dagko na kuan guys, na dagko na earthquake. Okay, the clustered seismicity of region 11 and vicinity. Ito na mga dagko na earthquake. Okay, so monitor ang kuan guys last time. Okay, these are the distribution of active faults. Okay, so imagine kana tanan no, kana mga solid lines no, kana mga na-legend dara. Solid lines, the trace is certain. Dash line trace is approximate. Then mga mao na siya. Okay. Then imagine guys in Davao City, so kulay zoom no kato akong gingon na 5. So tura guys no, mao nang murag experience kita karon og murag dagan na pag kuan lihok. Then di ba recently sige lang og kuan earthquake usually sa Davao Oriental ay Davao Occidental. So napo did ako na fault dere sa may kuan sa seashore dapit sa dagat, then napay Tangbulan fault. Okay, but let us focus here sa Davao City guys. Okay, so tula tong 5 ka fault guys. So Pangyaw Biaw, Takudaw, then Tamugan, Lacson fault, and also the New Carmen fault. Okay, mao na to mura big 5 na. Big 5 na earthquake. And imagine guys, doon lang kay sila. And as per P-Box, maulagi na tendency, basic kung mulihok ang isa, so basic matarog ba itong lain, no? Which will trigger shaking sa yuta. Okay, baka na ito siya. Ito mga faults guys, then so hopefully na research man ninyo, di ba? Last time. Okay, so anya na guys, kana ma-discuss na ko na niya. Okay, so mo ni kung ginaingon guys kani, di ba, gistoryahan na to tong peak ground acceleration kaganina. Okay, so pareha ni, di ba, anak ko na 0.4 G. Okay, so which is the maximum no, kay zone 4 naman tataman. Pero look at guys ang update sa P-Box. Okay, so ang update sa P-Box guys is wala na. So 0.45 na nagsugod guys, no? 0.45 hangtod 0.05 0.8. Okay, so kana siya. Ay, sorry. Pwede makuha guys. Anyway. Okay, so kana guys 0.75 ug 0.8 tapos nagsugod sa 0.45. So beyond na no, beyond sa zone 4. So then ang maximum bagid guys is 0.8 which is times 2, no, times 2 of the zone 4. Okay, so mo na murag kuan jud ta prepare jud ta kamay. So makita na ta dala guys. So this is the peak ground acceleration map of Metro Davao. 500 years return period on the site model. So pasabot ani guys, di ba kagayon na ingon to siya 10% of the chance sa 50 years to occur. So kani siya guys is 10% of chance to occur in 500 years no return period. And look at that, no, look at Davao City. So natay red guys. And I think this is the area kung asa tong mga faults. Okay? Kani mga red guys nakuan sa murag. Kuan din na siya gamay. Problema gina siya gamay. Sa ato no, kung hopefully dili lang gid siya ma-active. Ay. Then napay mga spectral acceleration guys. So, which will be discussed pa more later. Okay? So kato lang akong i-highlight ito. No, kato mga kuha na sa peak ground acceleration guys. So mo tong update sa PBOX. The next is the occupancy categories. Okay, so abot kabalo ka kung saan na-categorize ang building. So this is for the purpose of earthquake resistant design. So each structure shall be placed in one of the occupancy categories listed in the UBC 97 table 16-K. This consists of 5 occupancy categories with their functions defined. Okay, so ano guys, so dapat niyo may balaan. Okay. Occupancy category 1, essential ba siya, hazard, special occupancy, standard occupancy, or miscellaneous occupancy standard. We will discuss more of this, no? So essential facilities, so these are emergency facilities that must remain operational after an earthquake. Okay, so mao na siya. They include hospitals with surgery and emergency treatment facilities, fire and police stations, emergency preparedness structures, and government communication centers required for emergency response. Okay, so muuna mo siya essential facility pag gusto nimo guys na masking kusog yung linog, dapat after linog pag na-evaluate na safe siya, so pwede ba siya magamit sa inana operational gid dapat gyapon after the earthquake. Okay, so pareho na mga hospital, di ba? Kaya kailangan dyan na siya. Dili pwede na dili ma-occupy na after the earthquake. Okay, kaya essential man na siya. Essential needs man na siya sa tao. Okay. Next is hazardous facilities are used to store or support dangerous, toxic, or explosive chemicals or substance. Okay, so isa pa na siya. Special occupancy structures guys are designed to house a large numbers of people. So say for example for places of public assembly. So kung 5,000 or more ang tao guys, then mahulog siya sa special occupancy. No, kana mga crowded na mga structures, schools, no, kung 300 or more students, then college and full education adult education centers, 500 or more students po. Then nursing homes, daycare centers, nurseries, and jails. So kung asa to mga mga crowded na yung mga magtapok, ano na yung mga bata, so kana siya special occupancy structures guys na mahulog. Then standard occupancy structures, so all other structures that house occupancies or have functions not listed in special occupancy structures. Examples are apartment buildings, hotels, office buildings, and wholesale or retail structures. So, pwede na siya standard guys, standard occupancy. And lastly is the miscellaneous structures are buildings or parts of buildings classified as U or Group U occupancies. They include private garage, carport, sheds, factories, and agricultural buildings. Okay? Okay, so mga siya occupancy categories guys. And every occupancy categories guys natay mga nataan yung ginatawag na seismic importance factor na ginatawag is sa I. Okay, importance factor. So in table 16-K, so which increases the seismic design force for critical facilities. Okay, so muna yung mga corresponding I niya guys. So kung essential facility, no? So essential facility, then the seismic importance factor is I, then hazard 1.25, then special, standard, and miscellaneous is 1. Okay? So that is based on UBC guys, no? Sa UBC table 16-K. But since we have this again sa NECP 2015 table 208-1, so mas i-follow na to NECP guys. So ang mo po niya ko napansin guys na difference pa about sa essential facility, no? So 1.25 siya sa UBC pero sa 2A gimo 1.5. So gidungagag 0.25. I don't know kung anong gidungagan o kuan, no gidungagan og 0.25. Siguro kay gusto nila ma-strengthen pa, no? Ma-strengthen pa ang mga essential facilities, no? Mao siguro tong gi-increase nila. Then hazardous hantod sa miscellaneous is the same lang, no, with respect to UBC 97. So mo na i-follow seismic ni guys, seismic importance factor. So napo tayo seismic importance factor na IP na para asa man na siya. So ang IP guys is para na siya sa non-structural component design. Napo yung IW guys for wind design. Kay dito magud sa design sa wind, napod tayo importance factor dito actually na ginagamit. Pero sa seismic guys, o kani guys o kani na ito ang gamitin. So for essential and hazardous facilities, the prescribed design base shear is increased by 25% compared to other facilities. Increasing design base shear increase the seismic safety of the structure. Mo siguro di guys, na mo nitong tubag siguro guys sa nganong gidungagan ni 25%. Okay? Kay basig i-take account na nila ni kani na pwede di ay na prescribe man, no? Prescribe to increase by 25%. Okay? So, though ang gi-increasean lang guys is the essential lang, no? The essential facilities, pero sa hazard, yes, is lang niya. Okay? So, gikuan gid guys, gikuan gid yang ang pagka-essential sa facility. Okay, so mo siya. Next is the soil profile types. So, we have I think 6, no? Classified as SA through SF. Soft soil may amplify earthquake ground motion. So, mo nang ginaiwasan ginata na guys kanang soft soil, no? Kay pag humo kayang yuta, imagine guys kung humo kaayo tapos simuhang ugsukan og building, so for sure mag-settle dyan na, no? Mag-settle, then mag-liquefy sa mga inana. Then kung naay mga shaking, ground shaking, expect yun ka na mag-tilt ang building or mag-collapse na mga inana. So amplification of vibrations due to unfavorable soil conditions has been strikingly illustrated in many earthquakes. So kana amplification of vibration guys, so due to poor soil conditions. To that effect, the UBC 97 specifies that each site be assigned a soil profile type found by a properly substantiated geotechnical investigation. So, subsequently, the UBC 97 provides the site categorization procedure for the determining soil profile types. Okay, so mao ginakuha nila guys na nasindot ko na geotechnical investigation, though mahal gid gamay, no? Pero for high-rise structures, kailangan din na siya. Okay, geotechnical investigation. So dili lang gid siya for foundation lang gid guys, no? Dili lang, pero sa earthquake pod magamit siya. So in UBC 97, profiles are classified into 6 different soil types. So ranging from A is the hard rock, hantod sa E, soft soil. Then apo tay F guys. F assigned to these sites that require specific evaluation. So kailangan gyud siya evaluate siguro kay murag grabe na gyud ang kuan, ang tubig, no, sa yuta, or very soft na gyud ang soil, so kailangan yung evaluation guys. So in NSCP 2015, read the information given in section 208.4.3 site geological and soil characteristics. So pwede ninyo na dito pa studian guys sa NSCP 2015. So this is based on again sa UBC na guys, ha. No, okay, so how they classified the soil profile. Okay, so SA hard rock, SB rock, SC very dense soil and soft rock, SD steep soil, E soft soil, then F is the kailangan evaluation guys. So this may vary depending on their shear wave velocity and the way the standard penetration blows, no, per feet, and also sa undrained shear strength niya guys. Okay, so all of this is, I think, makuha gani siya sa geotechnical results, no, sa geotechnical evaluation, okay, sa geotechnical engineer. Ano? Sa NECP guys is money, no, sa NECP though halos the same lang, no, I think, no, halos the same lang sila o mga informations. So kana siya guys. Okay, so pakita na po na ko ni dito katong sa Metro Davao na yata sa Pibos guys. Okay, so muna guys, na siya soil classification map. Okay, do ang problema lang gamay guys is murag digid kayo makita dayon na kung asa po na lugar. Do sa Davao City, makita na sa Davao City guys, more on dark blue, no, dark blue and sky blue. So unsa man na siya. So dark blue and sky blue, so more on class B ta. Okay, nasa B halos guys, B og C. Okay, so wait, murag ang kuan day guys is nibog man niyang water bodies eh. Siya sa blue, then napoy pagka green guys, no, na yung mga pagka green. So D, no, usually steep soil, no, napoy mga steep soils guys dali dapita na mga portion ana, and even dali sa gilid. Okay. So mabantayan niyo guys katong naka dark blue, which is the class B rock. So muro mga kuan siguro na mga bundok na, bundok mo na guys, Mount Apo siguro na kana siya. Okay, so more on dark blue guys, and nasa C og sa D, B halos kay nabilang. Then ang Tagum guys, Tagum Carmen, more on green, steep soil. Okay, na soft soil ganiyo na mga portion dere kanang hapit sa mga dagat dapit. Okay, so try to explore guys. Okay, pero to be sure gid guys, dapat nagay soil investigation. Okay, para ma-sure gid kung sa na classification. Okay, so seismic source classification. Okay, so in addition to the seismic zone, natay seismic zone, natay site soil profile classification, po tayo importance factor guys that were established by UBC 97. It also requires the proximity. So it also requires the proximity of each site to active source, seismic source or faults to be known. Okay, so kailangan po tayo makabalo kung unsa kalayo atong building, no? Kalayo atong building or unsa kaya ang murag possible, no? Possible magnitude sa ato ang possible magnitude na ma-experience atong structure. Okay? So these are three seismic source types that are recognized in the recent UBC 97. They range from the most active source A to the least active source C. So A, B, C lang na siya guys, no? Ito ang seismic source classification. So faults are classified by the maximum moment magnitude potential M and the slip rate SR. So let us see the UBC 97 table 16-U. Okay, so ano yan guys classify. So UBC na guys ha. So for type A guys, so these are faults that are capable of generating large magnitude occurrences and a high rate of seismic activity. So ang gina-expect guys kung i-type A nimo, gina-expect nimo na ang magnitude is more than or equal to 7. Okay, so murag usog-usog na dyan na guys, no? Type A. And with the slip rate, so slip rate guys, which is greater than or equal to 5 mm per year, no, ang pag-move no sa yuta. Then faults other than type A and C. So I think this is in between 7 siguro guys. Kana for example, kung nasa magnitude 7 pero ang slip rate niya is less than 5 mm, then mahulog siya sa B. Then what if kung ang slip rate guys is greater than 2 mm per year pero ang magnitude is less than 7, so B gapon na bilong. Pero pag greater than or equal to 6.5, then with this slip rate B gapon. Okay, so all other expected magnitude less than 6.5 is sa C. Okay, sa C mabilong. That is based on UBC 97 guys. But again, we have this counterpart which is the NECP 2015 table 208-4 which defines the types of seismic sources. The location and type of seismic sources to be used for design shall be established based on approved geological data. So the most recent mapping of active faults by the P-box. Okay, so naana siya guys, no, katong kanina. Problema na po is unsaon pag locate. Pero sige lang guys, no, kay katong mga active faults is dili gito siya expected to na dili to mag less than 6 ang magnitude ato. So that is either A or B gid guys, no, ang pag-classify siguro nato. Okay? But as a designer, no, kung gusto nyo ka manigurado nyo ka, dito na lang ka sa A, no, for the worst case scenario. Though ang mga last earthquakes na to na experience is I think 6.2, no, magnitude 6.2 katong mga sa December guys. Pinakakusog ata is 6.6, no? 6.6. So nahulog siya sa B, no, sa B to guys. Pero again, dili pa to big one, no. So we are expecting with a big one, so safer to assume that na seismic source type A na lang, no, kay para sure gid ang ato ang building. Though again, it's up to you, no, as a designer. So mali guys ang mga so greater than 7 to ganina na sa UBC ang A. Dali guys is national limitation until 8.4 because I think 8.4 is the largest magnitude that we have experienced here sa Philippines. Okay? So pag mo na yung mga maximum moment magnitude guys, then mahulog sa A. Then magnitude is within this range, so B. But if less than 6.5, then seismic source type C. Okay? So, pero pwede man, di ba, based sa inyong research guys, depende kung unsa tong mga expected magnitudes sa kuan, expected magnitudes sa katong 5 fault lines sa Davao City. So mamili na namo dali. Pero do not choose C, no, kay mga low rate seismic activity mo na siya, pero kabalubyat na nakakasug-usog na mga linog karan. So ang kalayaan na guys is wala siya sleep rate, no, like sleep rate ang NSCP. So dili naman kayo siya necessary jud kaayo. Okay. So next is the near source factors guys, NA and NV. Okay, so in seismic zone 4, say parehado, Davao City seismic zone 4 man ta, no below. Each site shall be assigned near source factors in accordance with NECP 2015 tables 208-5 and 208-6 based on the seismic source type as set forth in seismic source classification. So for high-rise structures and essential facilities within 2 kilometers of a major fault, a site-specific seismic elastic design response spectrum is recommended to be obtained for the specific area. No, kay mula duol-duol naman god, so kailangan na tong response spectrum guys, which will be discussed later again. So the UBC 97 has adopted two near source factors NA and NB to minimize, so mo ang purpose guys to minimize this impact in seismic zone 4. So mo ang mga mao nang natay NANB tungod kay seismic zone 4, which is the severe shaking na sa structure. Okay, so based sa UBC guys, mao ni. So para makuha nimo ang NA ug NB guys, kailangan nimo ang kailangan nimo ni seismic source type. So kailangan makapili jud ka dito, A, B or C ba. Then kailangan ka makabalo kung unsa ang shortest distance to know seismic source. So kana siya guys, sige lang tudlon ta mo na unya. So, na ako'y mga new discoveries na pa na. So kani siya ang first table guys is for distance less than or equal to 2 kilometer. Okay, so say ang imuhang structure is less than 2 kilometers sa fault line, then you choose seismic source type A, then this will be your values, so 1.5, then 2. Okay, so kung nasakto guys, kung nasakto na 5 kilometer, within 5 kilometer, mo ni values 1.2, 1.6. Okay, but if greater than or equal to 10 kilometer, so kana, but less than 15 guys, less than 15 kilometers, so kana siya. Okay, so ang pangutana ani karon guys is, what if kung ang imuhang distance is 8 kilometers? O wala may 8 kilometers dala, di ba? Naman dali dapita ang 8 kilometers. Unsaon nimo na siya? So what you will do is kana interpolation. Okay? So practice interpolation guys, kana. So sa UBC na siya guys, try na nato sa NECP. Okay? Sa NECP guys is kani siya. Ang NA niya is walay 15 kilometer. No, ang NCP na ay 15 kilometer sa NV. Okay? So mo na nakalindot kay mura mas dali sabton, no? Mas dali sabton ang NCP guys. Table 208-5 and 6. So again kato, kung A tapos kung more than gani, kung more than 10 kilometer, 1 na siya. Kana siya. Okay? Kana. So again, pag 8 sa ibuhatan, interpolation. Example, 3 kilometers, interpolation na po. Okay? Interpolate. The same with NV. Yan siya guys. Okay, we have these notes. So the near source factors may be based on the linear. Okay, so do not worry, this is linear interpolation only. So kanaman po gyud kuan guys, napoy tawag ani. Napoy logarithmic. Okay. So hopefully kabalo mo atong sa calculator guys on how to interpolate using your calculator using the stat mode. Okay, so kato siya guys. Kung wala dito ang distance, then try to interpolate. Pag Pa greater than 10 kilometers, wala problema na. Okay? Wala kung more than sa NB, kung more than 15 kilometers, wala na problema, wala na interpolation ana. Okay, so the closest distance to seismic source shall be taken as the minimum distance between the site and the area described by the vertical projection of the source on the surface. So the surface projection need not included portions of the surface at depths of 10 km or greater. So the largest value of the near source factor, considering all sources, should be used for design. Okay, so para masabtan ni guys, nani drawing, no? So this is the explanation for that, no, kanina drawing. So kung naa imo ang structure dere, say for example, naa imong structure dere guys, then you have this fault, no, mo na imong fault line kana. Okay. So kung mao na imong fault line, so di ba mao man ang end, isa ka end sa imong fault line. So this will be your shortest distance. Okay? With reference to this building. Okay? Then kung mao ni ang kani guys, kung kanina fault seismic source, mao ni ang ginatawag na surface projection of seismic source. Okay? So dapat guys, kung from the surface, no, from the surface, then padulong dito sa baba, ang imuhang reference ana is 10 km lang jud ang pinaka maximum. So example, nadre mong building, di ba? So pag nana siya sa 10 km vertical projection ana, so dara ra ang shortest distance from the fault. Okay, with reference to this building. Okay? So okay, tendency magulana guys, pwede pa na siya moana dito, di ba? Pwede pa na siya moana dito. So say moabot og 15 km. Dili na siya ni may consider. Ayun na, no? So you will not consider this. Ay mo na i-consider is from the surface to the end of the fault, dapat 10 km lang gyud ang vertical projection. Okay? So kana. Okay, so mao ang mga shortest distance sa fault. So base man gud ay kuan sa problem. Okay, pero nga na lang siguro, introduce na lang ko to niya guys. On how to determine the distance, these distances guys, sa fault. So, seismic response coefficients, CA and CV. So, these seismic response coefficients account for the increased severity of the ground motion at a specific site and are influenced by the seismic zone, proximity of the site to active seismic source, and the site soil profile. So kung kaganina guys, kung kanina ang NA o NV, ang maka-affect lang is ang distance and seismic source, kani murag nagandaghan considerations pag-abot sa CA o sa CV. Okay, nato dala si Z, nato dala tong distance again, proximity no sa active fault, and naa na to soil profile dali dapat. So, CA functions as an acceleration control coefficient for the shortest period portion of the spectrum, while CV serves as a velocity control coefficient for the long period portion of the spectrum. Ito, CA o CV. Again, so, for UBC 97, so mo na iya guys. So, nato mga seismic ito mga profiles ay seismic zone, no? Seismic zone factors. Then we have this profile. So I think dili magamit ni, no? Kaning 3 kanipod kay wala man toy 2A o 2B. So dito ta sa NECP guys. Okay? So sa NECP 2015 tables 208-7, so mo na yung table for CA. So kailangan natay soil profile, no? Soil profile type. Then napunta ato seismic zone nato. Okay? So again, normally sa Pilipinas is seismic zone man kita mahulog. So nata dali seismic zone. So 0.4 ang Z. Say ang atong profile is SD. So mo niya to guys. So our value for CA is kana. So 0.44 of NA. So kailangan na po nato tong NA guys. So kailangan matun-an po tong NA o NV dito sa PICAS. On the same with CB guys. So kung seismic zone 4 na po da, seismic zone 4, then D ang profile, then our CB is 0.64 of NB. Okay? So kana guys, mo na to mga values for CA and CB. So isolve yun na siya no. Kaya na may mga NA o NB. Okay kana. Okay, so this will help you guys kaning hazard hunter PH no kato ko ang pag-locate niyo sa distance. Okay, sa closest distance from the fault line. So what is hazard hunter guys? So hazard hunter PH is a tool that can be used to generate indicative hazard assessment reports on the user's specific location. So it helps us a reference of property owners. So money guys as reference na property owners, buyers, land developers, planners, stockholders, and even mga kita mga engineer ana. So nganong appeal man ni sila no kay apektado man po na sila sa kuan guys sa kanang mga fault no pareha na kung nakayuta tapos mopalit ka tapos nakabalo ka na fault so mubaba ang presyo no kay uy naman day na fault line dara so pasabot dapat barato magana. Okay, kay murag dili man safety ana. So kana siya guys. So it aims to increase people's awareness to natural hazards and advocate the implementation of plans to prepare for and mitigate the effects of hazards. So dili lang kaning hazard hunter guys, dili lang gid earthquake ni. So mga natural hazards such as floods, then mga I think na po ni siya atong mga landslide sa mga inana. So all information used for the calculation of hazard assessment results are based on the most recent updates provided by the corresponding mandated government agencies through the GeoRIS PH integrated system. Okay, so Hazard Hunter is a product of GeoRIS Philippines. So a multi-agency initiative led by sila ng mga agencies guys. So led by DOST PBOX, then tabangan po sila sa DOST Pag-asa, ASTI, MGB, NAMRIA, OCD, o sa DepEd. So GeoRIS PH acknowledge the valuable contribution of the Geological Survey of Japan for training. The team is developing the application. So tabangan po to sa Japan na guys to generate this Hazard Hunter. Okay, so for more information about Hazard Hunter PH, so please visit the link below. Okay, so this link guys. And tagan na po tamong sample. Just a sneak peek lang sa Hazard Hunter. So pag pag-type niyo sa Hazard Hunter guys, so mo ninyo makita na. Then mga mga agencies, then pwede niyo na siya mabasahan niyo na guys. Then in here na yung mga how to use the app. Okay, the frequently asked questions, then the terms used na para masabtan niyo siya. So kana guys, so pwede niyo na siya ikuan. So proceed. So mo ninyo makita guys sa Hazard Hunter. Kana siya sa Philippines, then kita na to mga kwanta sa Davao ana. So say for example guys, say pakitaw na to sa bangkal bangkal man ko sa bangkal Davao City. Ano siya guys, matag na siya kuan sa bangkal din. Okay, sa mga kita niyo dali sa kilid guys kana. Uy. Ano guys, so pwede nyo na siya kanan. Kani guys, kani pareha na guys sa 7 day click ka dala kuan. Click ka dala isa ka establishment, then double click nimo. So magkuha na siya guys, mag-calculate na siya ka hazard assessment. Okay, so nato nimo. Okay, so see the results. Okay, so tara guys. So pag-click na to ato na specific location guys, kana ambot kinsa nang balay, no, kana na balay. So makita na to dira guys, the nearest active fault is si kuan, si Central Davao Fault System. And tarawa guys ang iyahang distance, no, nearest distance or closest distance is 523 meters lang. So dool kayo 0.5 kilometer lang guys. So, imagine. Okay, so inana ka dool lang. So asa na magamit dito sa NA at sa NA ug NV. No, kaniya? Okay, so kana guys. So sa 2 less than 2 kilometers. Okay, so sample A ta dala, so 1.5 ang NA. So pag abot po sa NB 2. Okay, kung A ka, seismic source type A. Mana. So ground rupture safe ka. Ang problema guys sa ground shaking. So prone ka sa ground shaking. So which is intensity 8. So sayang lang guys kaya ang given niya is intensity 8. Intensity dili magnitude, no, kay pwede unta to sa seismic source type. Do try na lang po niyo research kung unsa ang magnitude na nainani na effect, no, na intensity. Tara guys, earthquake induced landslide safe, liquefaction safe, safe po sa tsunami, no, kana. No, tsunami pala guys, makatag mo na siya. Kana mga information. Then sa flood, moderate susceptibility siya, no, kay possible na kung kusog ang ulan, then there would be 0.5 to 1 meter flood height. And or 1 to 3 days of flooding. Okay, so muna siya. So pwede ninyo na i-view ang report. Pwede po niyo i-download guys, no. Pwede i-view na siya, no, by just clicking this view report with recommendations. So mata lang siya PDF file guys sa report. Na to sa assessment. Na guys, so this is the seismic hazard assessment. Okay, so na mga kuan nila guys, na mga informations dala. Okay, so for preparedness po na siya guys. So napod sa kuan nata guys, so hangin, no, severe wind. So mga posible na mga hangin, so storm surge and others. Okay, so try na lang yun na kuan explore guys. Okay, naman na siya sa slides. Okay, so just visit this site guys kana. Then example, no, sample lang guys sa ato mga lesson. So a public library building with a 6,000 person capacity is being designed for the northern part of California. So the building will be the vicinity of San Andreas Fault. So the surface projection of this fault plane is as shown. So money guys. So plan view, then say this is the okay, so seismic source fault. Then the distance, no, from point A, wala siya distance guys. So I think ma-minus na siya niya. From B, so 10 kilometer, no, katong vertical projection. So dala. So this is the projection guys sa katong kuan sa fault, 12 kilometer, no, bago siya nag 10 kilometer vertical projection. So we have these questions guys. What is the importance factor? The soil profile type, the near source factors, NA and NV, then the seismic response coefficient, the CA and CB. Okay, so these are the solutions, guys. So because of the 6,000 person capacity, so this is more than 5,000 persons. So as discussed kanina, no? So take note, ang building is a library, no, public library siya, guys. So for sure, this is not an essential, no, facility. Also, this is not a hazardous facility. So this is a social function, no, na social function ng building. Then more than 5,000 persons. So based on the UBC nga kanina, so this will fall in special occupancy structure. Okay? And based on, ang gamito na to na table, guys, is NECP lang, guys, ha. So ayaw lang to sa UBC. So NECP lang itong gamitan. So if this is a special occupancy, then our importance factor is 1. Okay? So mao na to ang answer, guys, for importance factor. So for letter B, so I think this is murag kung ano ni siya, guys, kanang research na siguro niya ni, or given na lang ni, na given na ni siya, guys. So the building is located on a soil profile that is an average shear wave velocity of 3,000. So this is based on maybe the location, guys, no? The location of this, no, northern part of California. So mo na yung basis, guys, no, in dealing with this shear wave velocity. Ano? So based on site categorization procedure. So therefore the profile is type SB. Okay? So kana siya, guys. So dito na siya nagbase. Pero kung sa ato asa ta mag-base, no, pwede ta mag-base dito sa gihatag sa Metro Davao na assessment, no, kato na evaluation. Then pwede pa sa geotechnical results. Okay, so muna siya sa NCP, guys. So ako lang itabilit. So B. For C, guys, for NA and NV, so because the California fault, San Andreas fault in California is an active fault, so this is capable of generating high rate of seismic activity. So I think San Andreas fault, guys, is mo ni amurag dako-dako na fault dito sa California. So they are expecting that the earthquake is more than or greater than 7 in magnitude. So type A, guys, ang ilang type A niya gibilong. Then based on the surface projection of the fault, this is a non-vertical fault. So the shortest distance to the near source factor is given by this. Okay, so asa gikan ni, guys, 20 minus 12. So dito sa figure. So kani, guys. I-delete sa, guys. So dito gikan, guys. If this is the structure, kana, so 20 km sa B, pero ang near manggod, guys, ang closest distance is dapat kani. Okay, so dapat kana. Okay? So, mo dapat nila distance. So, mo to 20 minus the 12. Okay? Katong projection. Okay, mo ni, guys, surface projection. So, surface projection is 12. Okay? This is from A to B. Then, kaning 20 km, guys, is from the structure to B. Okay? Pero dapat manggod ang minimum distance is katong from structure to A. Okay, so mo to dapat. So, dapat ang answer is the answer is 8 km. Okay, mo na ang iyang kalayo. So, with seismic source type A, naman ta, seismic source type A, and the shortest distance is 8 km to the seismic source. So, the near source factor NA and NA and NV can be interpolated. Na ato ang interpolate, guys, no, kay wala may 8 dali. That is in between 5 and 10. No, og dali pod 5 and 10. So, interpolate niya yung duha ka values, guys, kani. Si 1.2 o si 1, no, kay A beta, ha. So, seismic source type A. So, interpolate niyo muna si 1.6 o si 1.24 and B. Okay, so ang result ana, guys, is ito ra. So, NA is equal to 1.08. Okay, so 1.08, then si NB is 1.36. Okay, so make sure guys na dili siya mulapas ani, no? Di siya mulapas ani 1.6, di ba siya mulapas ang 1.2 kay naman in between man na siya. No, in between 5 and 10 kilometers man na siya. Okay? So mao na to ang NA and NV. And lastly for CA and CV, so ganina classified as, ang soil is classified as B, no? SB. Then seismic zone 4, no, ang katong California, Northern California. Okay, so we have this CA. Mao na itong CA guys. So 0.4 of NA. The same with CV, SB, then seismic zone 4, then 0.4 of NV. So we have these values guys for NA na nakuha na to ganina. NA is 1.08 and NV is 1.36. So just substitute it here, no, sa mga equations na to nakuha dali okay, sa table. Okay, so therefore the values for CA is 0.432 and CV is 0.544.